Hi, I heard you wanted to learn about slope and constant rate of change, so I'm here to tell you all about it. So, with linear functions, the average rate of change is also known as the slope of a line. This is always constant with a linear function over the entire domain. That means you are adding or subtracting the same amount each time. There are multiple representations that you might see of slope. You could see it as m equals the change in y over the change in x. Also, sometimes, especially in my class, this is written as delta y over delta x. You can also see m is equal to rise over run. M is equal to vertical change over horizontal change. Or m is equal to y2 minus y1 over x2 minus x1. So you can see it in a few different ways, but it all means the same thing. You are measuring the steepness of a line. Slope can be positive, negative, zero, or undefined. The way I kind of remembered it was Mr. Slope Guy, and he looks like this. He has a long nose because a straight up and down line it has an undefined slope, and then he has a flat mouth with a slope of zero. So his eyebrow on the positive side is going up, his eyebrow on the negative side is going down, his nose is undefined, and his smile is flat. So it has a slope of zero. And you can also just remember the graph, right? Positive slope. As the x values increase, the y values increase. The line is going up. If you were Bertram, you would be walking up the line. Negative slope, the line is going down. As the x values increase, the y values decrease. Bertram would be walking downhill. A zero slope, Bertram's favorite because he gets to just hang out there and do nothing. You would be laying down. And then an undefined slope is Bertram's least favorite because he can't even stand on it. He would just fall right off. The way that you can remember that a zero slope is just a flat horizontal line is that zero hoy, horizontal zero crosses the y-axis, and undefined is bucks, vertical. Undefined crosses the x-axis. Now remember, we read a graph like we read a book from left to right, and we can find the slope from an equation, graph, table, or 2 points. So in these 4 examples down here, I'm going to show you the way to find the slope in an equation, a graph, a table, or 2 points. So in an equation, we are going to look for the structure of y equals mx plus b, and we are going to follow that structure. We see in y equals mx plus b that m is always the coefficient of x. So if we look for the coefficient of x in a linear function, we can know that that is the slope. So in this case, the slope is equal to 1/2. Now on a graph, we are going to measure the slope of a line by first starting at the y-intercept, because that's where all lines start. And then we're going to find the next nice point. What do I mean by a nice point? I mean a point that crosses in a corner right here. And you can read what that point is really easily. So I start at the y-intercept and I count up the vertical distance to that next nice point, which is 1 unit. And then I count over 2 units to that next nice point. So my rise is 1 over my run, which is 2. Or you can think about it as my change in y over my change in x, or my vertical change over horizontal change. This is how we find the slope in a graph. And as you can see, it makes a nice little triangle. So the slope is 1/2. On the table, we are going to find the change in y over the change in x. Same idea, right? Follow the structure. We are looking for the change in y over the change in x. So first, let's look at this table. It says we have minutes t and feet h of t. Well, there's no x and y. How am I supposed to find the slope of this thing? Well, you can always look for the h of t That is going to be your dependent variable, or your f of x. And then time is usually going to be your x. So now I'm going to find the change in y, right? How much does it take to get from 6 to 10? I add 4. That's my change in y. And then now I'm going to find my change in x. How much does it take to get from 9 to 11? You add 2. So my slope is equal to my change in y, which was plus 4, over my change in x, which was plus 2. 4 divided by 2 is 2. And then it says, don't forget the units. Well, my change in y was measured in, get out of here. My change in y was measured in feet. My change in x was measured in time, minutes. So my units would be feet per minute. Okay, last but not least, 2 points. Whenever I have 2 points, I always just put it into a table. Okay, so this is an x, this is a y or an f of x, this is an x, this is a y or an f of x. I make myself a little handy dandy table. I put the points in. And then I find the change in y. How do I get from negative 11 to negative 8? I'm going to add 3. Change in x. How do I get from negative 5 to 1? I add 6. Slope is equal to the change in y over the change in x. You're going to put your 3 over your 6. And we have a slope of 1/2. You could also do this another way, where you have m is equal to y2 minus y1 over x2 minus x1. This is the same idea as what you did on the table, but I just find that the table structures it much better and it's much easier. This is still okay if that's how you learned it. Go on with your bad self. If the table is easy and an algorithm that you can use to approach the problem the same way every time, go for that. Go forth and slow.